Great presentation. We should move on. The second speaker in our session here this morning is Dr. Peter Johansson from Uppsala University Hospital in Sweden. And Peter is going to tell us about the work that he led within ProPASS on developing our ActiPASS software for the processing of Thigh-1 accelerometer data. Peter, over to you.
Thank you, Andrew. We'll see if you see my slides.
Yes, thank you.
Yes, great. Thank you for a nice introduction. Yes, I will tell you about the journey we've done with and also about this software that we call ActiPASS. That is the tool that is used within ProPASS now to process Thigh-1 accelerometer data. And I would start to also say that I've been project leading this, but the coding and most of that work has been done by my colleague Pasa. So the ActiPASS is a software specifically developed for ProPASS needs. That is, that it should be able to process raw accelerometer data. And the issue we had in ProPASS was that we had different cohorts had used different accelerometers. So there was a need for a software that could use data from any kind of accelerometer that had been placed on the thigh. So far right now we have support for activity devices, active pal devices, active graphs, and also the latest addition is the sense motions that we can use in ActiPASS. Another aim was to develop these algorithms to become open algorithms. And it should fit the ProPASS construct. So we should get variables out that fit this ProPASS construct that has been published earlier. That it should have the intensity zones, posture activity types, bout durations, and domain-specific sleep and awake. And we started that work from using the Acti4 algorithm. That has been used before, and that fitted this purpose. It has been used by a National Research Center for the Working Environment in Denmark and been developed there. And it has been validated in several different publications before. And within the framework of ProPASS, it has also been evaluated that do we get different results depending on what type of accelerometers we have done. And Patrick Crowley have published that where he compared different accelerometer devices and if we use the ActiPASS, Acti4 algorithm. But the issue with the Acti4 algorithm was that it has no algorithm to detect sleep. That is one part of the ProPASS construct. So what we did was that we developed a quite simple algorithm to detect sleep or estimate sleep from Thigh-1 accelerometers. And this work has been published last year. And what we did actually was that we let the male use the Thigh-1 accelerometers one overnight in their home, where we also registered the golden standard for registration of sleep, like polysomnography. And what we found was that we could estimate sleep. We had some kind of underestimation, about half an hour on the group level. And the precision is okay, I would say, at least if you look at how this compares with other estimates that where you use, for example, a diary, and then also if you use hip-1 or trunk-1 accelerometers or wrist-1 accelerometers. So in this paper, we publish also these comparisons with the results from other studies and where we have limited only to accelerometry data. I would also say that we should be aware of that we only measuring movement, and in order to measure sleep, then if you compare this with sensors that have other kind of data, then you will get a higher precision. But this is, I would say, comparable to other placements of the body. But then the next question is, when should the sleep algorithm be applied if you have your data? For example, we must know, before we could apply it, we must know the time in bed. Because this is a typical, how a typical results look like from ActiPASS, where we have a whole week, where the blue colors here are sleep, Yellow are sitting and other colors are different kind of activities. If we apply the sleep algorithm on the whole time, the whole week of data, what we will end up in is that we will also identify sleep during daytime. And how can we be sure that this is just not very sedentary time where it's totally still for a prolonged time? We cannot know. So one option could be that we say that, okay, we only run the sleep algorithm at night. But that's not a good option because we might have many participants with very irregular sleep patterns, for example, shift workers. And that would be also very interesting to and important to capture. So we want an algorithm should be independent on when the sleep pattern could occur. And then in ActiPASS, there is an option. You can use additional data from a diary that says that the time you went to bed and the time you went out of bed, for example. And then you just apply the sleep algorithm on this time. But it's not perfect to use this diary. Perhaps you know there could be a lot of issues with that. It increases the burden on data collection a lot. Therefore, we wanted an automatic way of doing this. And there are actually already algorithms developed based on 5-1 accelerometers to identify time in bed. Van der Berg had one that's published in 2016. But the issue with that one is that it was only limited to nighttime. PAL Technologies has their own proprietary algorithm, but then the issue is that it's proprietary and it's only ActiPASS devices that could be used for this. And Winkler has also published one algorithm, but that doesn't really differ between time in bed and non-wear. So we took inspiration from these algorithms and we developed another one that fit ProPASS construct. And then we used the fact that we wanted to first identify when someone was lying down, just from the thigh accelerometer. And that is possible to do because very often when you lie down, you also roll over to the side. And Kate Leiden had presented an algorithm that used this information to identify lying time. So we have done evaluation of that and implemented that in ActiPASS. And it's also published here by PASS and Hetiarchi. So what we do, if we have a whole week of data like this, the algorithm will find prolonged times that they have been lying down. And we call this could be potential time in bed. But as you see, that could be several times during a 24-hour. And then you will also come here to a situation, like in this situation E here, that it's actually someone that has been sitting a long time. We also think that could be a potential time in bed because the lying down algorithm is not perfect. If you lie down and never roll over to the side, that could be a misclassification of prolonged sitting. So we also flag these episodes at a potential bedtime. And then we go further like this and flag all the time that could be potential time in bed. And the next step we do is that we give each of these potential time in bed a score. If they have a long duration, we give them a higher score. If they are happening during nighttime, we give them a somewhat higher score. And if there's a lot of lying in the episode, we give it also a higher score. So in this situation, we could end up with this case where the green is the one with high score and red is the one with low score. And then we look at 48 hours time with a moving window going forward with that. And then we see, can we identify 2 potential time in bed? Then we would flag them at the most likely time in bed. So we do that. Here we have only 2, but here we will suddenly have 4 time in bed. And then we think that these 2, C and F, is the one most likely time in bed. And we go further here. Then we reevaluate these 4. We see that F and G is the most likely. G and A is only 2. That's okay. And then here we will think that these 2 are the most likely time in bed. So when we have that, we have identified what we call primary time in bed. And then we use the sleep algorithm on these times. And then we will end up with the sleep time and sleep intervals within this primary time bed. How well does this work then? Well, we have compared this with a study where we have data from also a diary. And in this study, the participants were asked to tell them, what time did you go to bed to sleep yesterday? And what time did you wake up today? And there were many worked shift work, so we were quite challenging population to do these evaluations on. And what we found was that out of 794 reported time in bed, ActiPASS identified 99.2%. So we think that's quite good. But ActiPASS also identifies some time in bed that was not reported by participants. But then it's really hard to know, like in this case, could it be that there's some missing data in the diary, or is it the true time in bed? It's very hard to know. So I will finalize this then to thank this is the help we have done with developing this work. And there's also a lot of other people that have given us support and feedback based in that. But these are one of the group that work with the ActiPASS development. And now ActiPASS has been used in the first two studies that Matthew and Joe will present about soon. And if those of you who are interested about ActiPASS, please go to our GitHub site where you will find the documentation. We're working on that still to make a documentation but more developed, but there's variable lists and we have the tool already there. So thank you.
Thank you, Peter. Really interesting presentation and such an important piece of work for